Yeah. A picture that's funny to look at is where, I don't know if you've seen, they did the comparison. They started with, because they had The Rock and, I'm trying to think of the comedian, Kevin Hart, because they had The Rock and Kevin Hart. Then they put The Rock next to Shaq. Then they put Shaq next to, gosh, I'm trying to think of the basketball player's name.
Q or whatever.
Yeah.
Yeah.
No.
It's like 7'11".
Yeah. Just see the height comparison between them. It's.
I like watching bodybuilding shows. Bodybuilders, like you think they're tall, but they're only like 5'9". Bodybuilders are short. There's this strongman. His name's Brian Shaw. He's 6'8", and he hosted a bodybuilding show one time, and they were all just like here to him.
Yeah, because it's just the amount of muscle to get built like that and be that. It's just harder. All right, guys. Before we get started, are there questions on the homework? Question on the homework assignments. Feel good with these here so far? All right. What we're talking about today is equations of lines. The first one we have is y equals mx plus b. This is one y'all are familiar with, this equation of line. Now there's two main parts of this here, y equals mx plus b. We have m, which is the slope, and b is the y-intercept. So they call it slope-intercept form. Kind of imaginative, yes? Not really. They just called it what it is. It has a slope. It has the y-intercept, so it's slope-intercept. Our next one is point slope. Well, again, m, it has our slope, and it has a point. Slope-intercept. Slope point. Y minus y1 equals m times x minus x1. So we call it point slope because it has a point and it has the slope. That's it. I mean, they literally called it exactly what it is. Now, given 2 points, there is technically a 2-point formula, but I don't feel any reason to actually use it, because the point or 2-point formula I wouldn't even write this down because, well, it is the same thing as point slope. The only thing we did is we took the equation for slope and replaced it with m. I think there's too much going on here to try to keep track of everything. I think it's better to just find the slope. y2 minus y1 over x2 minus x1, find that, and take that value and just plug it into point slope at that point. Because, again, I think there's just too much going on with this equation to try to keep track of everything all at once. Let's just find the slope and plug it in. It gets us to the same spot without having to make sure we keep everything in line. So you got the equation for slope down? Don't use that. No, because that there is just using slope and plugging it in for m. No reason to. Just find slope and plug it into point slope or slope intercept. Yeah. This here is the first one we're going to do. We're going to actually be looking at equations of lines. They gave us a graph, and they told us this graph shows the distance asteroid 2012 DA14 travels in x seconds. Write an equation of a line and interpret the slope. The asteroid came within 17,000, so the asteroid came within 17,200 miles of Earth in February 2013. About how far does it take the asteroid to travel that distance? Okay. So we have a few things we need to do. One, we need to find the equation of the line. Two, we need to interpret the slope. And three, we need to figure out how long it took it to travel the 17,200 miles. Okay, so we're doing three things. Let's start with interpreting the slope we're getting that. Well, to interpret the slope, we might need the slope. Yes? Great slope, our slope formula. M is equal to y2 minus y1 over x2 minus x1. y2 minus y1, change in y over the change in x. Change in y over change in x. Now they did give us 1 point. Specifically wrote out a single point on the graph, yes? 1524. Not 15, 524. So we can plug that in. We can plug in the y value as 24 and its corresponding x value as 5. Now with slope, whatever y value we put first, its corresponding x value has to go first. Whichever y value goes second, its corresponding x value has to go second. They have to line up. Distance, as long as the x's are together, y's are together in the formula, it works. Midpoint, as long as we got the x's together, y's together for midpoint, we're good. Order doesn't matter. Here, it does. Now, what's another nice point that they gave us on this graph? Because there is one. Zero, zero. It does intersect at 0, 0. So the other nice point is 0, 0. What that also tells us is that the y-intercept is value 0. Yeah. Okay. 24 minus 0. 5 minus 0. 5. Does 24 divide by 5 nicely? No. If we did divide it, we would get 4.8. But here we'll leave it as 24 fifths. We could write it as 4.8. We can leave it as 24 fifths. Both will work. But we did find the slope. Okay. We're ready to interpret the slope. All interpret the slope is, and what it's telling us is, what, written out in words, what is the slope telling us? What is it describing? Because if we look at this here, the x value is time in seconds, yes? The y value is distance in miles. So if we look at the slope, our time, because we always talk about x first, it's 5, yes? So here we're saying for every 5 seconds, it travels how far? 24 miles. We interpreted the slope. That's what the slope's telling us. Now, if we wrote it and simplified it to say 4.8, we would not say the same thing, because 4.8, we don't have a denominator anymore. So we're saying now for every second, it travels 4.8 miles. Okay? Anybody's car can go that fast? Don't think, yeah. Because what, about here to Siloam's about 20 miles, give or take? 15. So that means we could get from here to Siloam in less than 5 seconds? If we were able to travel that fast and go there, we'd probably miss the first turn. Because there'd be no way we're making that turn, traveling that fast. But again, this is an asteroid. Asteroids do travel faster than we can, or consistently. But this here is traveling for every 5 seconds. Every 5 seconds, it's going to travel 24 miles. Okay, so we look back up here. Interpret the slope. Done. Now we need to find the equation of a line. Yes? Part's done. We can box it. Now, we have two equations. We have point slope and we have slope intercept. Now we have the slope for both of them, that's fine. Now do we have the y-intercept? We do, right? Because the y-intercept is 0, 0, yes? Because if we have the y-intercept, we know the value where it crosses the y-axis on the graph. And the x value of the y-intercept will always be 0, because that's just the y-axis. Now here, incidentally, the y value is also 0. So since we do have that, we can use our y equals mx plus b. If we don't know the y-intercept, we'll use the point slope form. Now, could we have used the point slope form for this here? Well, yes. It would have still gotten us the same equation, but it would have taken a few more steps. Now, our slope, m, is 24 over 5, plus our value b, the value of the y-intercept, the y value of the y-intercept is 0, yes? Well, do we write plus 0? No. So y is equal to 24 over 5x. Okay. We interpreted the slope and we found the equation, yes? Now the only thing we have to do left to do is figure out how long it's going to take it to travel 17,200 miles. Well, we have an equation to do that, yes? And we're going to plug that 17,200 in. Do we plug it in as x or y? So 17,200, is it distance or time? Distance, yes? So x or y, which one corresponds to distance? Because that's the variable that it stands for. I'm sorry, that's a very bad joke. So we'll plug it into the y. Now we just need to solve, yes? So we have 17,200 is equal to 24 over 5x. What do we need to do to get the x by itself? We can. What would we multiply by? We would not actually multiply by 24 over 5. Because 24 over 5 and x, what operation is being done between them? They're being multiplied, right? So what's the operation we do to undo multiplication? Division, divide. Because we can divide both sides by 24 over 5. Luckily, we do have a calculator. 17,200 over 24 over 5 is 3,583.3 repeated. Or fractionally, we can say it's 3,583 and 1/3. Yes, and we could say seconds. It would be, because 3,583 and 1/3. So this is, well, this is not, well, we can't just straight translate that. What we would be translating for the miles per hour would be, because we have 24 over 5 miles per second, yes? Now this is helpful, especially with unit conversions. Now, we already have the miles, yes? So that's 1. Yep, that's going to need charged. So we have miles per second, yes? But we really need to convert seconds into minutes and minutes into hours. So seconds over minutes, minutes over hours, because we're wanting to cancel out. Because here the seconds and seconds would cancel, minutes and minutes. Well, there are 60 seconds in 1 minute, and there's 60 minutes in 1 hour. So the denominator 5 times 1 times 1 is 5. The numerator, we'd have 24 times 3,600. So it's approximately traveling at 17,280 miles per hour. Quick, quite fast. Questions on this here? We feel good about this here. We ready for the next one? The graph shows the remaining balance y on a car loan after making X monthly payments. Write an equation of the line, and interpret the slope and y-intercept. What is the remaining balance after 36 payments? So, first thing we need to do is find the slope, and then we can interpret it and the y-intercept. So slope. M is equal to y2 minus y1 over x2 minus x1. This time they did give us 2 points, yes? 0, 18 and 10, 15. Which of the 2 y values do we want to use first? You can just pick one. 0 and 18, so we'd have 18 on top, 0 on bottom, yes? The other y value is 15, and if you need something to write with, there's one right there on the blue cart in front of you. And at this point here, we can do the calculation, yes? We can do it by hand or let the calculator do it. Both will work just fine. 18 minus 15 is 3. 0 minus 10 is negative 10. So this is our slope. And if you're hearing a beeping noise, you're not crazy. It's this headset. Red dot means it's dying. Yeah. I don't think it's too loud for y'all, but it's right there in my ears. So, sidetrack. If we look at this here, 3 over 10. Now, the negative 10, I wouldn't so much treat it as the negative of it, because the 10 parts are payments, yes? So it's hard to say a negative with payments, but we could say for every 10 payments, the balance does what? Drops, goes down, decreases. All of those goes down by how much? Yes and no. And the no part of it lies in the graph. What does it tell us about the balance? The balance is, so it does say balance, yes? So we do have another piece of information. Thousands of dollars, yes? So it is 3, but it's actually $3,000. So it decreases by 3,000. Now they do this because instead of on like the y-axis writing 0, 6,000, 12,000, 15,000, 18,000, it's easier to write 0, 6, 12, 18. Because it fits better on the graph, it looks a little bit nicer, yes? Scales better. Same thing with all of y'all's car, the tachometer is in thousands. It doesn't have 1,002, it's just 1, 2, 3, 4, because it's easier to use. If we just say let's put the notion of it and just use the numbers. So we have this here. Now this one here also wants us to denote the y-intercept, yes? I will go and tell you the y-intercept. You can spell. Intercept is the starting amount. This is whatever the loan started out at. Because whenever the x value, number of payments, is 0, we haven't made any payments, so that should be the starting balance. Does that make sense? So that's all it is, especially when it says interpret the slope, interpret this. All it's asking for, what does it mean in the context of the problem? We have two things left. One of them, we need to find the equation of a line, and the other is we need to find out what is the remaining balance after 36 months. 36 payments. Now, my next question is, do we have the y-intercept? Yeah. Since we have the y-intercept, we can use our y equals mx plus b. We can plug m in, which is negative 3 over 10x plus 18. Because again, our b value is the y value of the y-intercept. Because the x value is always going to be 0. So it doesn't mean anything for us. We're ready for the last part. So now we need to find out what's the remaining balance after 36 payments, yes? Is payments going to be x or y? It's going to be x. Because if we look at the graph, the x-axis or y-axis is payments. X. So we would plug the 36 in for x. Now at this point here, again, we can type the whole thing into the calculator. Negative 3/10 times 36 plus 18 is 7.2. So our remaining balance is $7.20, yes? I don't think so. Because again, what's our y is always in for this year? 1,000. So it's not 7.2, it's really what? 7,200. Does that make sense? Because I mean, if we had $7.20 remaining on a loan, I'd hope you just pay that off and be done with the thing. But we have that there. Y'all will all end up taking a financial literacy class, a PFL. And the biggest thing I'd say, especially with car loans, don't get one over 6 years, 60 payments. You run the risk of being upside down. If you guys don't know what upside down is, it just means that you owe more on the car than what the car is worth. Which is neither here nor there, especially if the car's, it's not a great place to be. But if it's like a farm truck, you don't take it anywhere, you're not at too much of a risk. But if it's your daily driver and you have 4,000 left on it and it's worth $3,000, if someone hits it and the insurance totals it, they will give you the $3,000 for it. You can use the $3,000 to reduce the loan down to $1,000, and now you're going to have to still pay off that additional $1,000, and you don't even have the car anymore. Yep. So that's why being upside down is never a good thing. And if you start getting into that position, the best thing to do is find some way to make up the payments and get close to it and sell the thing off. Because if you're having trouble paying for it, there's no reason to keep it. Find something that works better. You know, but sometimes it is what it is. Questions on anything we've done so far? We're doing great on time. Yeah. This one here, the graph shows, huh? No, I was trying to figure out where we were at because I think the other hour we got to this problem was the last one we did. So we'll finish up here. The graph shows the distance Allison hikes in X hours. Write an equation of the line. Interpret the slope of how long it will take Allison to hike 14 miles at the same rate. Okay. So we need to find slope first. Yes? Random side thought. Does anybody know why we use M for slope? Because it seemed to be better if we used, what, S, right? S is slope. Well, it's not so much it's taken, but a lot of mathematics, again, is done by the Greeks. Greeks have gotten more of a rep for it, but especially a lot of the Middle East Arab nations, Mesopotamians, had a lot more discoveries than the Greeks did. But from that area, especially that area, is where we actually get algebra. Is actually from the word algebar, which means bringing back together to make whole. That's why we get algebra. It's from algebar. And most likely M is coming from our word that we get for an increase. So going up, an increase in elevation, which is also where we get our word for mountain, montagne. M is why they have that. That's the best, especially from what I've heard. It's coming from its actual origins, not so much our English interpretation of it. But let's find the slope. One of the nice y values they gave us is 24.5. The x value is 7. What's our other point? 0, 0. So we had 24.5 over 7. We can't leave it as this. We can't have a decimal and a fraction together. We got to have one or the other. Well, luckily, the calculator, 24.5 over 7 is 3.5. This one we'll do as a decimal because I do want to show you guys one as a decimal, one as a fraction. Because if we wanted to, we could change this to a fraction. Because if we change this to a fraction, it'd be 7/2. Would be our fraction. But our slope as a decimal is 3.5. And if we interpret this slope, so time for each hour. Because we don't have a denominator. Our denominator is essentially 1. Even though it is a decimal, it's still 1. So our amount of time is just 1 hour. For each hour, she hikes how far? 3.5 miles. There we go. We've interpreted the slope. Now we need to write the equation of a line, yes? Okay. Let's use, so we'll have y. Do we have the y-intercept? Yeah, 0, 0. So we can use our y equals mx plus b. Because our slope is 3.5 x, and our b is 0. So we don't even need to add it in because it is 0. All right. Equation done. Now the only thing we have left is to see how long it'll take her to travel. 14 miles. Yes. Now since it is, miles is our distance, we're going to plug it in for y. Last thing we need to do is divide 14 by 3.5. We're dividing both sides by 3.5. And 14 divided by 3.5 is 4. And that's it. Questions on this here? Okay.